I think we start. We'll get through the boilerplate stuff first. So I can't see the chat at the moment, so if anyone needs to draw something to my attention, please do so. I've asked Nick to be made a chair as well, which will help, but hasn't happened yet. Right, so welcome to this meeting of the joint meeting of the PALS, Mpls and DetNet working groups. Here is the note. Well, I am sure that everyone is familiar with that, so we won't dwell on that any longer. So the purpose of this meeting is a joint meeting of the three working groups, and it's being called to discuss the basic architectural issues and solution proposals arising from drafts that proposed new application uses at the bottom of the MPLS label stack. The general structure of the meeting is as follows. We're going to start with a status report on the open design team work to date. And then we're going to go through use cases, requirements and framework. Then we're going to look at a number of related technical proposals. And then we have 30 minutes at the end, if we all run to plan, to for an open discussion on the design team work. So here is the agenda. I propose that we do a small bash that I'll come to. So we're in section one here. Lower is going to present and talk about the design team work in his report. Then Tarek is going to talk about the use cases. Then we'll move to Matthew talking about requirements. So slots 3 and 4 would swap. Lower will then talk about the framework. Jags will talk about a solution draft on extension header. Bruno on entropy label ID. 2 slots by Kariti. It's up to you how you spend your 15 minutes, Kariti, but after 15 minutes, we will then go to an open discussion on the ODT activities. I'll just leave this for a couple of moments. So all this material is available via the data tracker anyway, but these are the resource links for the where you find the agenda, where you find the docs, where the Jabber room is, where the ODT wiki is, which is where we've been keeping all of the minutes meeting information, etc. If there's any general issues with Meet Echo, please talk to support@ietf.org, and there should be a Meet Echo team monitoring us. So we're up to 40. I am now going to share a different set of slides and hand us over to, how do I do this, to Lower. ODT report, share, and
okay. Are you going to?
Yeah, you tell me when you want me to move across one.
Okay. I have a comment on the wiki on your presentation. The wiki is not very well organized. It's possible to go through it and actually glean out the information, but you need to take your time if you're new to it. Okay, open the design team report. Next slide, please. So the open design team is actually said to be an MPLS open design team, but it's actually a joint activity between three working groups, DetNet, Mpls, and PALS. And from time to time, the chairs are having coordination meetings and to coordinate agenda and possible decisions. The design team meet every Thursday And it's very early in California and very late in Asia. Actually, just now, since I'm in Asia, I end the meeting well into Friday. The participation is about 20 participants each week. It might be peaks depending on what topic is discussed. And there are about 20 documents that the design team are discussing. Next. And I'm using the term documents a little bit freely there because some of the discussions are on things that are in the wiki. Next slide, please. MIAD, we started something that is kind of very close to what the design team is. We call it the MIAD, and that's an Mpls indicator and ancillary data project. And what we set out to do is actually to define an architecture that allows you to use a data plane to send instructions between layers and LSRs and requesting actions are related to an LSP. We talk about, and here I had a comment that is not very clear what I mean. The square brackets are actually are alternatives. So we talk about forwarding actions, and that's in Kiretis document. We talk about network action, and then it's in John Drake's text in the wiki, and we talk about MIAD actions as a alternative name, and then there are suggestions that we just talk about actions and don't design them more than that. And we would actually like to prefer to pick one of those before progressing documents too far. Preferably before or just after making the working group documents. We also talk about ancillary data, and ancillary data is data that is used to perform the actions requested, and it's also sent in the packet. Next slide, please. We have at least two types of documents. One type of document are what I call guiding, and this is not an IETF term, this is my term. And in that group, I count requirements, framework, and use cases. And then they have documents that I say are specifying, and that is mostly the solutions document. Next slide, please. The next steps, we have wanted to start progressing documents for some time. Firstly, by adopting them as working group document. What stopped us so far is that some of the documents, at least in my mind, are not compatible, so we can't move both of them. We would prefer to lead with the guiding documents, but we also like to move the solutions document as soon after as we can. The procedures are the standard IETF Mpls procedures. There will be consensus call on all three working groups, but actually discussion will take place on the Mpls list. We're still discussing the process a little bit, whether we can start progressing, for example, a solutions document before all things are sorted out. The next bullet is possibly being overridden. The end-to-end discussion is we don't have the consensus among the chairs to actually do the poll, so it's on hold. The indicator name will probably be solved in the framework and requirements drafts. And then if we want to use a new or a special purpose label, or if we want to have a new one, that is, if we want to use an old one, that is still under discussion. Next slide, please. So one thing that wasn't clear for me when we started the project was that the MIAD is a little bit different. Normally, the traditional MPLS uses a control plane and signaling between the nodes to tell the LSR what to do. But in MIAD, we actually use the data stream to send information with the packet between the nodes, and that actually brings a strong dependency on hardware. And the design team has had quite a number of discussions on hardware optimizing coding. In my mind, there is no strong consensus yet, but I think we are getting nearer. Was that the last slide? Next one.
That's the last one, isn't it, Loa?
Yeah, okay.
Yeah, okay.
I thought so.
I thought so.
Questions? Sorry, say again, Loa?
I would prefer that you mute yourself if you get an echo. So, do we have any questions? Okay, guess not. I mute myself now, and then you can go on.
Thank you, Loa. So it's Tarek next. I'll stop these. And requirements, use cases.
Hello.
Okay, over to you, Tarek.
Okay. Can you hear me? Just a confirmation that you can hear me. Hello?
Yes, I can hear you.
Okay, great. Thank you. So hello, everyone. My name is Tarek Saad, and I'm going to talk about the use cases for MPLS indicators and ancillary data. Indeed, as Loa mentioned, there are variants. And on my slide, I call them function indicators. In other cases, they are action indicators, and so on. So I'm yet introducing another term to describe these indicators. So we need the action, take that action to align and pick up one term for the indicators description. I am presenting on behalf of the co-authors. We are part of the open design team. The objective of this document to compile the use cases for MIAD that the design team has been discussing in the weekly calls. So we have attempted to cover what has been discussed so far and what's documented on our wiki. We are welcome to add more to the document or even update what we have. Next slide, please. A bit of overview, although Loa had given a bit of introduction. Again, sorry, go back, please. One slide. Okay. So the MPLS function indicators and ancillary data MIAD attempts to address requirements from new MPLS applications. These require inclusion of an indicator inside the MPLS packet to allow specific functions to be invoked on the packet as the packet traverses the LSP path. Ancillary data may be included to supplement the invocation of such specific functions and actions. These ancillary data are added by the ingress LER, and they're added along with the user traffic. They may be updated by transit LSRs and LER as the packet traverses the LSP, and they're disposed of and removed by the egress LER. Next slide, please. So in terms of use cases that we have compiled, the first one talks about no further reroute. We have a reference for the document that introduced this use case. There are cases where we have fast reroute protection, and after the failure, we reroute traffic on the backup path. But then on the back, while the packets are traversing the backup path, there could be another secondary event, a failure event, and still another FRR can happen on the backup path itself, and rerouting the packets towards the original PLR. In that case, there could be a loop that could happen between the two PLRs, the first PLR and the second event PLR. There is an example in the document described where we have multi-homing and edge protection, and CEPE links fail. The pair of PEs are protecting each other. So the first event, the PE would send to the other PE, and then the second event, the other PE will send back to the first PE, and we have that loop. So basically, no further reroute is an indicator inside the packet that tells any node that once carried inside the packet, tells any node acting as a PLR not to reroute again, or reroute is not allowed again if a failure is detected. This is to disallow that loop, potential loop from happening. So this is the first use case that we compiled. The second use case is about in situ OEM. This is one flavor of OEM where we carry additional data inside the user plane traffic. So such data like telemetry or operational data like timestamps and so on is carried along with the user traffic. And these ancillary data can be updated along, by LSRs as the packet traverses the path. So there is a flavor of IOEM that touches the packet content hop by hop, and there is another flavor that's only edge to edge. So the requirement is to have such an IOEM function indicator carried inside the packet so that we can alert the nodes that need to process or update the IOEM ancillary data. Next slide, please. So the third use case that we touched upon is related to network slicing, and more specifically to network resource partition, which is the underlay, which is a partitioning of the underlay network. In that case, if we are partitioning the underlay network and assigning resources to different partitions, there is a need to identify the packets belonging to one network resource partition and then apply the per hop behavior or the specific profile treatment on that packet. So there is a requirement to carry a resource selector function indicator, I called it, or a flow aggregate selector in other documents, so that the LSRs are able to invoke the per hop behavior. So this is the third use case. The fourth use case is related to time-sensitive networking. We have compiled this use case, and we admit that we haven't given it much investigation yet. We need to engage that net working group on their interest in covering this use case in more detail. But here it is. The Mpls packet can carry a timestamp or a time budget that enable routers to make queuing decisions when the packet is traversing an LSP. So, for example, they could prioritize sending out the packet if the time budget is shorter. As packet are forwarded along the path, we have a timestamp or budget associated with every hop, for example. So the requirement is for the packet to be marked with a time function indicator, and as well carry additional ancillary data, which is the timestamp that allow LSRs to use such a timestamp to prioritize and schedule the packet. This is related to the fourth use case we compiled. I believe this is the last one, but let me double check. Is there a next slide? There is. Okay, sorry. The fifth use case that we have compiled was related to network programming. We know about RFC 8986, which is network programming in SRv6 data plane. This RFC with that functionality, it allows an operator on an application to specify a packet processing program that to be encoded inside the packet, and as well a sequence of instructions inside the packet header. So once we carry this inside the packet, we can allow such a program to be run by the network on specific nodes. The Mpls packets may carry such a program instruction as a function indicator. So that's one thing we discussed during the design team as a potential functionality that could come out from MIAD, is that carrying such a program inside the packet, as well as some arguments that we can pass along so that we can run that function or program. And those arguments can be the ancillary data carried with the packet. And the last use case that we compiled in this report was related to service function chaining. There is an RFC in Mpls that modeled service function chaining header by emulating the NSH network service header inside the label stack. So there was no need for an extension header to carry the network service, the NSH. But using MIAD, we're able to carry the ancillary data, and we need to do some further investigation if carrying the NSH as ancillary data is superior to emulating the NSH inside the label stack. These were the use cases that we have compiled. In terms of next steps, some of the documented use cases were driven by application requirements that we know about. There's interest from the field in solving these use cases. Other require further investigation and validation, as I pointed. We would welcome operators and other experts to engage and sound their opinion on this. As usual, we welcome further input from the working groups, and addition and update to the document is welcome. Thank you, and sorry if I took more time than allotted.
We're absolutely bang on time. Are there any questions?
Yes, I. This is Manchu from Siena. So what does the PALS stands for? And why is this MIAD work getting done in PALS and not in MPLS?
Okay. I think your question is to the chair.
All right, so it's actually being done jointly in the three working groups, and the reason that PALS has an interest is that PALS it was the first, and then DetNet was the second system that carried data below the bottom of stack in order to process the packets. So in part, this is to make sure that we don't trip over any of the historic work, and that those systems continue to work properly. As to why this is tagged a PALS meeting, it is entirely sort of procedural and administrative, because we couldn't do it all in one slot, and so we requested a second slot to deal with this particular thing. MPLS will follow in doing its normal work. Wim, I think you're next.
Yeah, Nokia. Is this better?
There's back to
Maybe can people mute if we speak?
Yeah,
Is it better now?
Hello, can you hear this one?
Yeah,
I think it's better, but I think the other people have to mute if we speak properly. My question was the following, Tarek. I think it's first of all very good overview. My point was a bit on the number 5 of the use cases. If you do 5, would you not cover all the others? Because five is the So 5 is network programming. In my view, it's a bit of the overarching thing that you can do. So if you do 5, if you do 5, let's say, well, then you probably have covered the other ones as well.
So good point, Wim. Let me try to answer that. So indeed, as I mentioned, some of the application requirements, some of the requirements were driven by use cases brought forward from the field. The number 5 was an aspiration. As you say, if we model number 5, we can model any function or any program to be invoked on the packet. The question is, it's under investigation. This is what I put in between brackets, and it's an aspiration. The question to the working group is this of interest to the working group and to the operators? Is this solving specific problems to them that we want to bring about this type of use case? But it's a valid point that you're raising.
And my point is, if you look at 5, I mean, it's maybe a good reflection on the other use case, because if you do, let's say, have a general, in my view, 5 is a bit of a general structure to be able to do multiple things, right? At least that's the theory. And if you could see that you can model the other use cases by doing 5, that would then we have a generic mechanism to do multiple use cases potentially. I don't know whether it's possible or not, but that's how I personally see it.
So MIAD is indeed generic. MIAD is not, we're not designing specific solutions for specific application. The design team has, put itself to design a generic way to solve this problem. So indeed, if we can use this generic solution for number 5, then it will be more comprehensive.
You're here on mute.
Sorry. We got some time at the end. I'd like to continue this discussion, which seems to be of an overarching sort of type, at the end, please. So we can move on with the base information we need to start the discussion. So next is Matthew.
Sure. Thank you. Can you hear me? Macos.
Where's the requirements gone?
There we go. Thank you. So this presentation is about the MIAD requirements draft. The that Stuart and I have been editing, but it's very much an output of the open design team. We had a lot of review and discussion of the points in the requirements draft during the open DT meetings. Next slide, please. So this document captures the key requirements for both the ancillary data and the indicators in the MPLS label stack that support. I've written network actions there, but as was indicated, as Laura indicated early on, there's some discussion around the exact terminology here that use that ancillary data. As mentioned, it's a product of the MPLS open design team. So the requirements we've got in there were largely derived from looking at the proposals for additions to the MPLS label stack. So looking at some of the solutions that were proposed, looking at the use cases, to allow decisions about those actions based on application data. And that application data, so that's the ancillary data, can exist within or below the label stack. And the actions can be performed by intermediate or transit LSRs or terminating LSRs for the LSP. I should make clear that the requirements are on the protocol design work, not on what implementations have to support, as I think is generally the case for the requirements documents in these projects in the IETF. Next slide, please. So the draft is structured into kind of 4 sections. We tried to define some of the base terminology, and the terminology work that we did here was done generally before the framework draft, although some of the terminology may end up being standardized really in the framework drafts, and so we may need to update this part. Some general requirements are kind of a set of design principles that underpin the work. Requirements on the ancillary data indicators. So there's the indicators in the label stack for the presence of ancillary data and what to do with it. And requirements on the ancillary data itself. Next slide. So I just wanted to highlight some of the key new terminology that we started by defining in this draft. And these may change depending on the framework draft, or details of this terminology may change depending on the ongoing work in the framework draft. So the first one is the ancillary data. So this is defined in this requirements draft as data relating to the MPLS packet that may be used to affect the forwarding or other processing of that packet, either an LER or an LSR. And this data may be encoded within the label stack, so it's termed in-stack data, or and or after the bottom of the label stack, and that's termed post-stack data. The second major new term is the ancillary data indicator, or ADI. So this is an indicator in the MPLS label stack that ancillary data exists in the packet. It can also indicate the specific type of the ancillary data. So it gives some indications on how to process the ancillary data in that case. We also tried to define end-to-end and hop by hop, but really these need to be defined these are really architectural concepts, and they need to be defined really in the framework draft. So I won't dwell on those here. Next, general requirements. So this is the first of the main requirement sections. And these are mainly about ensuring consistency of the design with MPLS and the efficiency of the protocol. And I've just copied a few of the main ones here from the requirements draft. So MPLS today combines extensibility, flexibility, and efficiency by using a control plane context combined with some very simple data plane mechanisms to allow the network to make forwarding decisions about a packet. And we're not trying to change or break or be inconsistent with any of these properties. So any solution must maintain these kind of properties of MPLS in general. Any solutions to these requirements must not restrict the generality of the MPLS architecture. So what we meant by that, I think, was the ability of the MPLS architecture to evolve and be extended in future for new solutions. So we're not kind of nailing down a particular version of the MPLS architecture here. It's proven to be extremely flexible in the past. And by MPLS architecture, we mean what's defined in RFCs 3031 and 3032. If extensions to the MPLS data plane are required, they must not be inconsistent with the MPLS architecture. So we are going to try and use as much as possible the existing mechanisms provided by MPLS. The design of any mechanism should be such that an LSR is able to efficiently pass the label stack. And mechanisms, so that's basically don't detract from the existing very efficient data plane design of MPLS. And mechanisms must not add more labels to the label stack than is necessary. So try and constrain the size of the packets, because there's still a lot of hardware out there in deployed networks that would have issues parsing very large packets. Next slide. So then we have some requirements on the ancillary data indicators themselves. I won't go through all of these. There's quite a few in the draft, so I won't go through them all in this presentation. I just wanted to give you an overview of the intention of this section. So these are specific requirements on the design of ancillary data indicators, and then really address the following themes. So firstly, the need for an ADI at all. Coexistence of the ADI, which is in the label stack with existing MPLS mechanisms. The need for mechanisms to enable a head-end LER to know whether and where in a label stack to insert an ADI on the LSP. And ADI support for end-to-end and hop-by-hop processing of the ancillary data. Okay. Now, the next section is on requirements on the ancillary data itself. Now, these are quite high, obviously quite high level. We're not necessarily designing the details of the ancillary data, but we need to at least have sufficient protocol design work to identify what the ancillary data is and roughly what to do with it. So these are high level requirements, and then address a set of themes. The first is coexistence of the ancillary data, which could be in the label stack with existing MPLS mechanisms. And also coexistence with post-stack mechanisms such as control words or generic ACHs. The next one's around protocol efficiency. So ensuring ancillary data is not too deep in the packet. So we don't have to parse through a whole bunch of other layer 4 headers, for example, or layer 3 headers in the packet before we hit the ancillary data. Whether processing impacts the immediate forwarding operation or if misordering is allowed. So we had a lot of discussion in the design team on fast path versus slow path processing and what this really means. And I know that there's other working groups in the IETF that are kind of grappling with this at the moment. I've been in a few meetings this week. So we were trying to come up with some sort of text here that described this without going into the detail of the internals of the implementation and what we were really trying to achieve here. The scope of the ancillary data. So it could be, or may be control or maintenance related, or it may be related to the user traffic itself, if that's relevant to the action on the packet in the network. There's also a couple of requirements related to security, and we kind of recognize that we're going to need to, at some point, do some security work in this area to get this through the security area. That's one thing. And we identified a couple at this stage, and again, this is requirements on the kind of protocol design work that we need to do. This is not saying that everybody has to implement this. So the solution is needed. A solution is needed to verify the authenticity of ancillary data. So if I get some ancillary data, do I know it's where it came from? Is it authentic? Do I trust it? And the design shouldn't expose or must not expose confidential information to the underlying network. So it's basically maintaining the confidentiality of users' traffic to the underlying network. Next slide. So we've reviewed several versions of this draft, really line by line in the Mpls Open Design team. We know it needs a bit more editorial cleanup. When going through it, I spotted a couple of duplicate requirements. There's also an additional set of comments received on version 2, which we need to address, though we think they're fairly straightforward. And once we've done this, I think the authors believe the draft is quite mature now. It's been around for several months and through it will have been through 4 revisions by that point. It's mature and ready for the MPLS working group adoption. Okay, I think there's
you're first, I think.
Ketan, you have a question.
A question about in-stack data. Do the requirements have? Is there something in the requirement about say limiting it to a single label to kind of put a strict bound on how much can be carried in stack and probably more carried at the bottom of the stack?
That in the open design team. We've tried to make the question is how much is too much in the label stack. So the requirements draft as it stands is very much around saying, well, it mustn't be too big and it must be efficient to process. We don't have a requirement that says specifically how big that is. Like I understand your point, and we have discussed this to an extensive degree. Appreciate it.
Hi, I'm going to see. Oh, they fixed the echo. Great. So in the FAI document, we do have a couple of comments along these lines. So one is typically we want 4 octets per flag. There's one flag that has 2 bits, and so that can go up to 8 octets. The other thing that we've said about in-stack data is there needs to be, and I don't know how you finally implement this, maybe by having an expert team or expert commentary in, when you do the allocation in IANA. There has to be some sense of why this is so urgent that it needs to be in stack versus post stack. So I think that's so those 2 things are what has been guiding us so far in terms of what we put in stack and how much we put in stack. There is this whole other thing about if you want to go post stack, can you actually reach it and can you do something useful with it? And Matthew mentioned a little bit, but I think we could say more about that. So for example, if you can't, if your hardware either can't process it or it's a lot of overhead to process post-stack data, I think there needs to be something said about, is that okay? Or are there cases where you should drop the packet if you can't actually get there? But in terms of in-stack, that's in the FAI document.
Barmack.
You could generalize this and add a requirement that around or along the lines of what you were mentioning, Kriti, in that sense that we could say we could provide basically some justification has to be made in a solution for putting it in stack versus post stack. Like, why do you need it in stack? Because that has potential, if it's especially if it's large, could have a significant impact on the processing. I think Barmack.
Hello. So same concern for label stack tip, because there are some chipset like Broadcom widely used by some vendors. Only 3 label stack are supported, and I just wonder, is it possible to reuse some kind of like label bits or TTL or something else for MIAT, or it should be added somewhere, as you said, at the bottom or in a stack?
So Kariti, last comment, I think, unless Matthew wants to pick that up.
Yeah, I was going to. Matthew, do you want me to answer this, or are you going to do it?
I mean, there are solutions that have been proposed that reuse bits within, for example, a special purpose label. And there's solutions that have been proposed that have an extra additional flags field which follows a special purpose label. So there's both solutions kind of on the table at the moment in the open design team. But I think that some of this is kind of, we need some discussion around the framework as to exactly how we structure this in the label stack.
Agreed, but I think if you pop up a level, we're also looking at solutions that say, if I'm going past a node that can't process this, then how can we avoid going there, as opposed to seeing what we can do with a Broadcom chip that can only process 3 labels. So I think there's multiple ways of skinning this cat.
Indeed, there are requirements in the requirements draft about being able to, whether or not you be able to know that a downstream node can process at that depth. And exactly. Compressors to ADI and could process that ancillary data.
Jeff Tensura, a couple of points here to try to make successful. Number one, this functionality should be clearly explained to consumers of this technology. All of us who built routers, we know we would receive RFQ from a customer saying, I want you to support 5 labels. I need 2 labels for basic functionality, FRR, carrier over carrier, right? So same type of explanation needs to be provided to people who are going to use this technology. Otherwise, it's absolutely unclear what you need in stack, out of stack, how do you signal it. Number 2, thanks to segment routing, we've built some machinery in IGPs and BGPLS to provide this information. There are different types of MSD to provide what's support in terms of label imposition. There are other extensions to IGP that provides what's support in terms of depth of lookup. Please define this or ask an IGP to do this work already, so it can be signaled to either centralized entity or head end, to be clear not to impose data that cannot be read, or to impose data that cannot be read somewhere in the path and misroute the packet.
Queuing you up. You're on next. Lower, you're shown as, I can't hear you.
I pushed the wrong one. I pushed the hand instead of the mic. So you can hear me now? Can you hear me now?
Yes, we hear you.
Oh, okay, great. And please do unmute, otherwise I have an echo. So I would like to start to saying that I produced both my slide decks very close to the deadline that Andy and David set up. I got the first one in reasonable time, at least a couple of hours before the deadline. This one was not before the deadline, and I got a new deadline from David. But it actually means that it's my report. It's no one else actually saw the slides before they were posted. So if there are objections or want to make changes, you can chime in. So next slide, please. So a little bit talk about framework and architecture document. In my mind, and I've know that there are different opinions. A framework is a document that pretty much focus on how an entity interworks with its environment. An architecture is a document that focuses on how the entity works internally. Sometimes we put all this in the same document and then we talk about architectural frameworks. You can say that that is the best of two worlds in the same document. Next slide, please. So we, Matthew Stewart and I put this document together, and when we posted versions 01, we got mostly positive comments, and I was a little bit surprised. It should be noted that all three of us are very busy and we had very little time to actually work on the framework. We managed to make it, but when we sat down after actually posting it, we knew that there were a lot of work to be done. And what I say is that in that situation, we actually got a Christmas present. Next slide. We had other people that actually had been working along the same lines, especially John, Tony, and Adrian had been thinking around the same issues or issues that has a rather big overlap. So they sent us a lot of useful text that could be incorporated in the document. On a very high level, we are mostly in agreement. There are differences in how we want to name things and how actually what we call things. We haven't had an example of actually what do we call the indicators. I think I have 4 different proposals here today, and we need to kind of converge on that. Next slide, please. So when we post the next version or the next version of the document, I think that we will have a couple of more co-authors. Tony has already started to prepare a version 02 and circulated it to the other people on this list. Whether John and Adrian want to be co-authors, I don't know today, but they have to tell me. Next slide, please. So next steps are that Tony will take over holding the pen, at least for some time. We will post a new version after this IETF, and that version should be rather carefully reviewed and both by the open design team as such and in the working groups. And we need to converge on most of the terminology issues, or if we can't, it should be clearly documented in the framework. After the updates of the next version, that version we produce at that time would probably be ready for going to working group adoption poll. Next slide, or is that the last? Yeah, okay, so that's what I have. It's not with much just now, but I think we have a good start. And we clearly welcome Tony, Adrian, and John participate as part of the author team. Questions? No. Okay, thank you.
Jags, you're next up.
Thank you, Stuart. Hello, everyone. I'm going to present the Mpls extension header encoding that are defined in our draft on behalf of all our co-authors. And next slide, please. So we have described the abbreviation which we have used in the presentation as well as in the draft in this slide. Next slide, please. So this is the agenda. I'm just going to talk today with respect to our draft. Next slide, please. So there are many new applications are coming up with new requirements to carry an additional information in the MPLS packet to influence the MPLS packet forwarding or for the OIM purposes. This requires MPLS packet to carry more SPL or ESPL per application, and this will increase the MPLS stack depth size drastically. To solve this problem, we need a generic framework to build the MPLS extension header encoding format that would carry multiple forwarding instructions in the MPLS label stack or after the bottom of MPLS label stack. Our draft mainly complies with the MIAD requirements, which has been described before. So the main objective of this draft is MPLS packet should be able to carry two type of forwarding instructions. One is flag-based instruction that does not need any ancillary data. Another one is the forwarding instruction that needs ancillary data. The second one is MPLS packet to carry additional data after the bottom of stack. And third one is any combination of instack and MPLS bottom of stack forwarding instructions could coexist in the same MPLS packet. And the fourth one is the new solution which we are going to propose is a backward compatibility. Next slide, please. Before diving into the solution, I want to let you know that we have done an extensive hardware analysis to come up with a implementable, ASIC-friendly, and futuristic solution. The MPLS extension header mainly consists of two parts. One is the MPLS extension header indicator. So this indicates the presence of MPLS extension in the packet. The next one is the MPLS extension header format, the format in which the MPLS extension could be carried in the MPLS packet. Next slide, please. Let us see the different options of MPLS extension header indicator. So option one is to extend the existing ELI, EL by repurposing the EL's TC and TTL field to indicate the presence of the MPLS extension header. Option two is to assign a new special purpose label to indicate the presence of the MPLS extension header. And option three is to use user configured label to indicate the presence of the MPLS extension header. Each option has its own advantages and disadvantages. We could choose the options based on our discussion on the IETF working group. So here in this data structure, so if you see there are important fields there. The first field is the instack data length field. So this is actually a sort of a 3-bit length field. This indicates the instack MPLS extension in the order of 4 bytes. Some of the parser would require the length of the instack MPLS extension for the easy parsing. The next one is the instack MPLS extension header presence indicator. This is a bit field that indicates the presence of the instack extension header. And next one is the bottom of the stack MPLS extension header presence indicator. A bit field indicates the presence of the BOSS MPLS extension header. The fourth one is the hop by hop BOSS MPLS extension header indicator. A bit field indicates the presence of BOSS MPLS extension header that needs to be processed hop by hop. Next slide, please. So this is the instack extension header and its data encoding format. So here we see the main part is the instack MPLS extension header. So this contains the bit flag, which the IPI flag, which we have described before, to indicate the presence of instack MPLS extension header. And apart from that, we have the instack data length. This indicates the instack MPLS extension length in the order of 4 bytes. The next one is the instack MPLS extension format. This contains the opcode, so instack forwarding instruction opcode. This is of 8-bit value that defines the forwarding instruction that need to be executed when it receives the packet. And next one is instack data. So this is the ancillary data which is required to execute the forwarding instruction. So we use the 2 bits to control this instack data processing. So one is the D bit, which is shown in the diagram. So that is this is the data stacking bit. In the case of instack forwarding instruction, requires more than 20 bits of ancillary data. Then this bit is used to extend and carry more bits of ancillary data. If this is bit is set, then this will be the end of the ancillary data for the specific forwarding instruction. The next bit we can use it here is the E bit, which is shown in the diagram, is the end-to-end bit. So this indicates whether this forwarding instruction has to be processed hop by hop or end-to-end. If it is hop by hop, then this will be set to 0. So the R is a reserved one, which we are not currently using. So we're coming to the instack forwarding instruction opcode assignment. The value 1, we have reserved it to carry the flag-based forwarding instruction. In some cases, the application does not need any does not need any ancillary data. So in those cases, they could assign a bit by the IANA, and they could use this opcode and then carry those kind of informations. And then value 2 is optionally used to identify the byte offset of the boss data location. So this makes it more flexible to encode the bottom of the stack Mpls extension data anywhere after the bottom of the stack. And value 3 to 254 must be assigned by IANA upon the application request. So value 255 is used to extend the opcode range beyond the opcode value 255. This is for extending our design in the future. Next slide, please. This is the bottom of the stack Mpls extension header encoding format. So this contains the boss Mpls extension indicator. So this contains the this has the boss extension header presence indicator field. This must be set to indicate the presence of the boss Mpls extension header after the bottom of the stack. And next bit which is used for this purpose is the hop by hop boss extension header indicator. This field is to indicate the presence of boss extension header that requires hop by hop processing. So this makes it easier for the parser to dig into to move and examine the data which is present after the bottom of the stack on all the hops. Next one is the boss data format. Here we are defining a generic framework so that we could carry multiple forwarding instruction with respect to the boss forwarding instruction. So the first nibble is a fixed 0010 nibble. This is used to avoid aliasing with any existing IPv4, v6, etc. data packets. And next nibble is reserved. And next octet is the boss forwarding instruction opcode. So this value will be assigned by IANA based on the application request. The next octet indicates the length of the boss ancillary data in the order of 4 bytes. This boss ancillary data could have its own TLV and sub-TLVs. Next octet is used for boss Mpls extension header flags. Currently, 2 flags has been assigned. One flag is the next header presence flag. This indicates the presence of another boss Mpls forwarding extension header. And next flag is the hop by hop bit flag. So we can encode multiple boss data, multiple boss Mpls extension forwarding. So we can, by this flag, we can indicate that this boss forwarding instruction requires a hop by hop processing. Next slide, please. So this is an example of the instack Mpls extension header carrying the flag-based instructions. As we described before, Opcode 1 is reserved to carry this kind of forwarding instruction, which does not need any ancillary data to process the forwarding instruction. In the first word, the IPI is set to 1, indicates the presence of the instack Mpls header presence, and the instack length is set to 1, indicates that instack extension header length is of 1 word. In the second word, the instack forwarding instruction opcode is set to value 1. It indicates in this it indicates that it carries the F5 flag, and in the case of DS bit, it is set to 1. That means that this is the end of the F5 flags it is carrying. In this, the E2E bit is set to 1, so this means that it requires an hop-by-hop processing. Can you please move to the next slide? So this is an example in which instack Mpls extension carries more than 20 bits of data. In some cases, the application needs to carry more than 20 bits. So this is how the data format looks like. So the important thing here is that the third word, if you see here, so the first bit of the MSB should be set to 1 to prevent the auxiliary data value from aliasing with the existing SPLs on the legacy routers. Next slide, please. Yeah, so this is an example of Mpls packet carrying the BOSS Mpls extension header. In this example, Mpls packet is carrying 2 BOSS forwarding instructions and its corresponding auxiliary data, and the values are set as per what we described before. Next slide, please. This shows a sample packet comparison between the option 1, that is extending the ELI as a Mpls extension indicator, versus option 2, that is using a new SPL as a Mpls extension indicator. So in this case, option 1 will consume maximum Mpls stack, the Mpls stack depth of 5, while option 2 will consume Mpls stack depth of 7. This is just to show the difference. Next one, please. So as a next step, we would welcome review comments and feedbacks, especially feedback on the Mpls extension indicators options. Also, we would request Mpls working group adoption. Before I complete, I want to mention that we have done the hardware analysis study on the Mpls extension headers, and those informations are provided in the appendix for this presentation. People can take a look whenever they want. Yeah, thank you.
There are some other slides beyond this that I'm seeing on my screen.
Those are the appendix actually.
Okay.
That is the hardware analysis we have done.
Okay, all right. So if you don't want to talk to that, then we'll go to the questions. Is that how you want to proceed?
Sure.
Okay,
Thank
so Tarek is first.
Tarek Saad with Juniper. My question is on slide 7, please. If you don't mind going back to slide 7. One of the requirements of the MEAD is to be able to carry multiple function indicators or multiple indicators in the same packet. If in such a case we have multiple instructions or indicators, some of them are end-to-end, and some of them are hop-by-hop, what would the end-to-end bit indicate? Is it per, I mean, I see you have a bit, but is it a bit per header, or is it a bit for each instruction?
Okay, so it is for each instruction, the bit will be set. For the let's take an example. I have 2 opcodes, opcode 8 and opcode 9, right? So opcode 8 is assigned to application 1. If that opcode 8 needs to be processed hop by hop, then the E bit will be set to 0. And if the opcode 9 needs to be processed end to end, then actually E bit will be set to 1.
So the full header will be repeated for every instruction, right?
Not the full header. Full header in sense like the opcode and instack data will be repeated for multiple.
Okay.
The IPI equal to 1 and the IL will not be repeated. Only the opcode and the instack data. The in this case, right? You see that as the second word will be repeated.
There was too much lag in the system. Greg?
Can you go to the next slide? Yes. Okay. So in case when their entropy label indicator is the top of the stack and the node does not support this new interpretation of entropy label indicator. So their node will pop up the entropy label indicator and the next label element, exposing their data. So I guess that will really cause the packet to be dropped.
Yes. So Greg, actually in our draft section number 10, we said that we need signaling for the compatibility for the LER routers to support this Mpls extension header. So that will take care of, make sure that the router which is going to pop is aware of this extension
Okay,
headers.
so basically you require that all nodes in your domain support new entropy label indicator interpretation.
That's right. The LER router should know about that.
So you're saying that it simplifies their deployment because you reuse the entropy label indicator for MEAD, but then you say that all nodes needs to be updated. Then,
not all nodes.
What's the difference comparing this approach with assigning a new special purpose label to indicate MEAD?
Yeah, first of all, we give it 3 options, right? And then we will see the advantages of all the 3 options. One of the options is whatever you're seeing here, the entropy, using entropy label. Other option is using the new SPL label. So the advantage of entropy label is that it is going to carry the entropy, which is needed for most of the cases. And also the label stack comparison, which I showed you, is going to be less. And so these are the things, we think will be helpful if you carry entropy, if you reuse the entropy label. So this is one of the options, that is it. So, and other options is the SPL, and third option is the user-defined label. So these are the options we are keeping on table, and then our IETF as our group, we can just discuss and choose which one to go with.
Well, it's confusing a little bit because you are listing many options and asking the community to choose rather than proposing one specific solution. Can you decide which option you're proposing?
So I'm saying each option has its own advantage and disadvantage, right? So I want the community to know about these options, and then we can come up with which one is we need to choose.
I think the office needs to decide that. But okay, thank you.
Can we pick up the pace a bit, please? It's How You next.
Why I appreciate author puts this together, but I'd like to raise awareness to authors that a couple years ago we have published a document talking about different options for the extension header indicator, which includes the option of reusing the entropy label to do that. And also we have several other options also cover the using a special label, and particularly in our proposal, we prefer to use a single special label. And also we have another document talking about the format of the post stack data, how to encode the extension headers. I think this um, this also published 3 years ago, and we have continued to update it until now. It's a version 6. So I think the author here is propose some kind of new encoding method, and should to at least to mention that document, and maybe make some comparisons why the author want to propose a different format, and what's difference, and what's the benefit, what pros and cons, like something like that.
Sure, I will.
G.
From my understanding of this presentation, if we want to carry both the in-stack data and the post-stack data, do we need to have two special purpose label or the two entropy labeled indicators in the label stack?
No, it's only one. That's the reason. No, like we have the bits, right? So the BPI bits, the HPI and IPI. So these are the bits we'll be using it. So only one indicator is enough.
But in that case, the in-stack data will be put after the entropy label, and it is at the bottom of the stack.
That's right. Yeah, so we have given an example in our draft, where it carries both in-stack and bottom of the stack data.
Okay, so that's in case like the MSD issue, you need to have another in-stack data block, which is not at the bottom stack, right?
I didn't understand your question.
Yeah, to solve the limitation of the label stack gaps on some transit nodes, you need to carry another special purpose label or the entropy label indicator, which can be read by the transit nodes. In that case, we will need two special purpose labels in the label stack entry, one for the in-stack data, another one for the post-stack data.
No need actually, like I said, right? So the bits are going to explain now, like whether it is just the indicator, it's just a bit indicator saying that I have some data after the bottom of the stack. That's it.
But the bottom of the stack label does not have to be the, it can be any label before the bottom stack block.
Yeah, it could be any label there.
Okay, maybe I'm not sure this can maybe misread by some legacy nodes, because the first only using the first nibble to parse the existence of the bottom stack.
Okay, so as I told you, right? So we have an option where we can say that the opcode 2 be set, right? So optionally, we can have the offset of the bottom of the stack Mpls header location 2. So if you're going to encode more information,
can we either discuss in the open discussion at the end, or take it to the list, please?
Okay.
Thank you.
Yeah, sure.
So it's now Bruno, I believe.
Yes, thank you. Bruno de Kram from Orange speaking. Hopefully you can hear me. So the proposal is a proposal to carry indicators in the existing entropy label. Next slide, please. So a recap on the existing entropy label. It is defined in RFC 6790. It is used for load balancing. And it uses a stack of two labels. First is the entropy label indicator, aka ELI. It is a special purpose label 7. and it is followed by the entropy label, which is a per flow entropy value. What is of interest for us is that the TTL field of the entropy label is essentially reserved for future use. It is defined as being must be 0 when sent and ignored when received. So next slide, please. So the proposal is to extend the TTL field of the entropy label and to redefine it as the entropy label control field. That would give us 8 flags or 8 indicators. And we propose that the semantic of those bits be user defined, so not IANA standardized, in order to maximize the reusability of this resource, of this number of flags. So essentially, that's all. It's very straightforward. Next one. In terms of benefits, compared to using a new special purpose label, first one, in my opinion, is that we have a faster deployment with incremental benefit. This is because most, if not all, existing egress LER already support ELI, so they won't drop the packet. They already signal that they support it. And therefore, any new ingress LER may use the feature, so may use indicators. So if we assume that 25% of LER support the feature, we would be able to use it for 25% of the flows, or at least the LER. Compared to if we use if we define a new SPL, we would only be able to use it for 6% of the flows, because we will need both the ingress and the egress to support the new SPL. So this is the main benefit for deployment. Second benefit is to minimize the label stack when load balancing is required, because you can add indicators with no additional labels in the stack. That's true that you could define a new SPL and define for that new SPL the ability to advertise an entropy label, or whatever the name. But for a large number of years, we would need to send both the ELI and the new SPL in order to be compatible with both new and old LSR. And finally, we have a special purpose label on the associated signaling in protocols. Next slide, please. So the draft give examples of use case to use indicators. So one is end-to-end absolute loss measurement using alternate marking. So you can signal that you want to encode the slice ID in the entropy label. Obviously, it's not a limiting number of use cases, and Tarek has proposed another one, some other ones. Next one, next slide, please. So next step, it's an individual draft since December 2020. We have presented it 3 times. There are some discussion in the Mpls working group and also in the open design team. We would welcome more review and comments, and we believe draft is mature enough to request a call for adoption in the Mpls working group, because it's an extension to an Mpls document. And that's all for me.
Greg, your turn.
Hi, Bruno. Thank you for presentation. I just wonder, in your opinion, how this proposal is related to the previous presentation?
It can be used independently. The main goal is to advertise indicators in the packet, in the stack. Now you're free to use indicators to indicate whatever you want. So if you want to indicate an extension, you do so. I'm not sure to get your answer. It's mostly independent in the way that you can use indicators as a general capability to indicate whatever you want. And anyone is free to use indicator to signal something. So not sure if this answers your question, but
because in my understanding that so what your proposal is arguing is that only 11 indicators can be used with no ancillary data following in stack.
correct.
And that seems to be too little and does not really conform, well, does not conform to the requirements.
So the proposal can use a set of indicators while being fully compatible with entropy level. We propose the indicators to be user-defined to maximize reusability. If you need more than 8 or 11 indicators, it's possible to extend the proposal by putting new labels. But if you do that, so if specific autonomous systems do that, clearly you lose compatibility with the existing egress supporting only the entropy level. So I think it's fair to have the autonomous system requiring a lot of indicators to support the cost of it, and allow autonomous systems to be happy with 8 indicators to benefit from the compatibility with the existing entropy level. But it's a personal opinion.
Rakesh, your go.
Hi. Thanks, Bruno, for the presentation. I think I just had one comment is that I think Bruno draft is independent and it can progress as a working group document, while the JAX draft is more about the ASIC or hardware-friendly encoding, and it can have we showed that different encode the indicators. And ELI bit can be one of the indicator options. So it's this draft, the Bruno draft is independent and it can progress. I think another advantage that should be listed is the backwards compatibility on the existing legacy nodes for the Bruno draft. So that's also a very strong advantage for this to proceed. Thanks.
Thank you, Rakesh.
Very short question. Greg mentioned some requirements. Do we really foresee that we need more than 8 values here? I mean, outside of boiling the ocean.
Is it the question for me? Or I can't answer for the working group.
It's either for you or for Greg. So, I mean, 8 seems like a reasonable number given the we preserve backwards compatibility. Do we really see breaking point where we need to look forward saying 8 is not enough, so we need to do something else?
I agree with you, Jeff. I think 8 is enough, at least to start with indicators. If we really need more than 8 for a given autonomous system, we can extend, but I agree with you that we could start with 8.
Thank you.
So can the other questions go after Kariti? Kariti, you've got, I'd like to finish you in 10 minutes if we could total. And could you please focus on new work rather than work that you've discussed at a previous meeting? Thank you. Sorry to cut you off a bit.
Sure. So next slide, please. So the first thing I want to say is that the draft is functionally stable. We're still wrangling bits. We're doing a few things like that, but we're not actually adding new functionality. There was one piece of functionality that we hadn't gone into in any detail, which we might come back to. which is this whole thing about user-defined. You want me to stand there? I can see from here. I can see from there. Yeah. But the reason why we're bringing the draft here, to Stuart, to your point, there are some decisions that we do have to make, and ideally, that the work group will make that decision. So that's what I'll get to in this deck. And once we have those decisions, or in parallel, adopt the document as a working group document. So we've been working on this for over a year now, and we've presented a few times, we've made some changes, and so I think we're fairly mature at this point. There are things we still have to do, and I don't think that precludes it becoming a working group document. We want to write down more about how this works in the presence of, in a brownfield network, how you deal with backward compatibility and so on, what kind of extensibility we want and how much, the exact bit formats, as I said, we're playing with that still, IANA allocation details, and deployment strategies. Next slide, please. So the three key contributions here are that we can use a single SPL for multiple purposes, and that addresses the problem of running out of SPLs, which is something that we constantly worry about in the Mpls working group. We use the full label entry, which includes the TC and TTL fields, and we encode forwarding actions very succinctly, and both 2 and 3 are for efficiency. Next. So we're going to pose a number of questions for the working group, or maybe working groups, because there are multiple working groups involved. We'll pose it here. Hopefully we get some sort of direction, but of course we will repeat it to the mailing list and then act on it from there. Our opinions will be noted for each of these questions, our being the authors. Oh, I should have mentioned, we have a new author. Tony Lee has joined the group, and he has contributed already. So thank you for that, Tony. So if we do an initial poll here, I think that will help in terms of knowing what the direction this is that we're taking. But of course, in the end, we have to do it by email and have the larger majority in the group speak. Next. So this should be an obvious one, but is there a value in stack data? And the only reason I want to bring it up here is that there's a constant undertone that all MEAD data should be post-stack. We already have an existence proof of stuff that is in stack. I just want this to be ratified by the working group so that we can put that particular question to bed. So I give a couple of reasons here why in-stack is valuable, in-stack data. Reaching the bottom of stack can be expensive or even impossible for some chips. And even if it's possible, it's more efficient to use in-stack data for stuff that's critical for forwarding. So the entropy label is an example, a slice indicator, whether or not to perform fast readout. So we think that it's really important to put things in the stack as opposed to putting everything after the end of stack. So the question for the working group is, what do you think about this? And can we arrive at some kind of consensus on the guidelines? We went into this a little bit during Matthew's presentation. What do you put in stack? When do you put it? How big can it be? And our opinion is, yes, we need in stack data, and we have some guidelines in the draft. We can expand on those, but we'd like the working group to give us the go-ahead. Next. Should we repeat the in-stack data in the post-stack data? This was thrown out in one of the design team meetings. I don't think this is worth it. I don't like repeating stuff. There's always the chance that you don't get it right, you don't encode it correctly, and then if there's a conflict, which one do you take? But again, I think it would be nice to get feedback from the working group and then, settle this. Next. We think that this approach is very efficient and very extensible. An action is essentially encoded in a single bit, and the position of the bit number, says what the action is. And the value can be 0 or 1. 0 means don't do it. There is no associated data ever. And 1 means do it, do whatever the action is. And whether there's associated data or not and how big it is something that needs to be put in the IANA registry. So typically, it's either 0 or 4 octets of associated data. The number of flag bits is extensible, so there's an extension header that says use another label stack entry for more flags. So again, there's been questions about how do we encode these things. I think we need the working group to step in and say, yeah, what you guys are doing is wonderful, because of course it is. We do have people who are looking at this from a hardware implementation point of view. And, we have a co-author, Israel from Broadcom, and we have internal people who write ASICs and microboard and stuff, and they're pretty happy with it. But again, we'd like the working group or working groups to say, yes, go ahead with this approach. Next. The one exception to this flags being 1 bit is there's a 2-bit flag for the combination of entropy label and GIS. And there's a summary of how this works in the top right. Question, I guess, is, what this gives you is a much more flexibility in how many bits you have for entropy and how many you have for slice ID. But is this too clever? And this is, I think, a question for people who want to implement this. So the question to the working group is it useful to have this flexibility? And if it is, it is beholden on us to investigate the complexity of the hardware that supports this. But there is a value that, in many cases, you only use 1 LSE instead of 2. If you did 1 bit per action, then you'd always have 2 LSEs. And you'd always have very big entropy and very big GIS. And maybe that's not the best way of doing things. Next. And I guess this is the last one. Can the special purpose label reach the top of stack? Until now, we've been saying, because we're reusing the TC and TTL bits, we don't want it to reach the top of stack. But if we have the right signaling that says, I can deal with it if the FAI, SPL, or whatever you want to call it, reaches the top of stack, then I think we have more flexibility. The 3 sort of choices here are never let this happen, which is kind of what the current document says. The second is to allow this to happen, and if you pop the top label, which is the forwarding label, and send the FAI label to the next LSR, it has to be able to deal with it. Or the third is, if you don't like that happening, push a neutral label on top of stack. So for example, label 0. This is not something we have to decide right away. There is some flexibility involved. There's also some potential for bad things to happen. So that's something I think the working group should think through. Next. So as I said, we're doing some arm wrestling around some of these bits. Continuation bits is what we currently have. We have a request to put an explicit length. It makes it much easier to know exactly how much to pop. The bit positions we might want to play with in terms of put all the things that have no associated data first, or put all the things that are really important first, or stuff like that. Again, semantically, it won't change anything, but it might make it easy for the hardware. We don't have a detailed IANA section. We need that, especially in the INS section, you have to do things like say, what's the length of the data associated with this, and does the data come in stack or post stack? And then there's a bunch of procedures we have to write down. And I think that would be good, so that this is deployable. And we look through some of the scenarios that could happen if you start using this. So again, we'd like to get the working group feedback on the questions which were in slides 5 through 9. And yeah, working group adoption. I don't think the working group adoption is contingent on any of this happening. This document, as I said, is pretty stable, but whatever the working groups decide. Questions?
Preeti, I don't think there's time to do mass replies to these today, and I suppose with foresight we would have set up an electronic survey. Maybe we should ask the chairs to set up an electronic survey to get some consolidated information for your questions.
Yeah, I mean, the other thing is we could just send email to the list, one per question, and so either way.
A million answers to text answers. So Rakesh, you're first, then Darren, and then we're going to go to Kriti's second slot.
Thanks, Kirti. So I think you asked for working group adoption for this draft, and I just wanted to point out that there are also 2 other solution drafts as well, and they are also asking for working group adoption as well. So I think just to highlight, there are multiple drafts requesting the same. So probably need some more discussion on that. And that's all. Thanks.
It's not a question for me. Next.
Hopefully my. Yeah, it is working. Yeah, so I just had a comment, and maybe this will go to the email list. Stuart, well, you can tell me. But anyway, the item number 3, you had a set of bits indicating the functionality, and that seems good until there's some ancillary data associated with those bits. And I understand that it would be implementable in hardware, but what the hardware has to do then is go from a bit presence to some data that may appear later, to another bit being present, some data that may appear after that, and it needs to bounce around in order to accomplish that. I have a concern with that encoding. Maybe, I don't know if we have time today to discuss it or if we'll go to the list, but that's my main comment.
So as I said, we have people who are looking at this from an implementation point of view. And there's an algorithm in the document about how to process this. It is sequential because the presence of an earlier bit being 1 makes, moves the data around. So if an earlier bit has associated data, let's say there's an entropy label, that means the first label stack entry following this would have the entropy label. If that bit happens to be 0, the first label stack entry would be some other thing. So we are well aware of that. As I said, so far the implementation seems to be straightforward. But yes, we are taking that into account.
Can you now fly? Can you fly through the next one, and then we'll take all of the other questions that people have got for this, together with all of the questions that people have got outstanding for other things, as part of the final wrap up.
Okay. Yeah. So a bunch of us got together, you can see the authors here, to write essentially an IANA registry for the first nibble, which is the first 4 bits that follow the label stack, which is look for the last label, the one with the bottom of stack bit set, and then the first nibble after that. Next slide. So the reason we want to do this is a lot of people were thinking that the first nibble would be similar to IP version number, and we can use 0 or 1, but we can't use anything else. What this document basically says is we've got 16 values. We're going to use all 16, except we are not going to use 4 and 6. This is not an IP version number registry. And the reason why 4 and 6 are special is because people came up with this really bad hack that if it is 4 or 6, It might be an IP address. It turns out to be a really bad hack. So this also says, here's a requirement and here's a recommendation. Next slide, please. So the requirement is, if you're not putting an IP packet directly after the label stack, so it could be either 4 or 6, then you must use a post-stack header. This is sort of what RFC 4928 says, but we're trying to make it stronger. And so it's not just for Ethernet, just anything that you do, whether it's beer, whether it's, I don't know what else you want to do, you should, if it is not IPv4 or IPv6, just put a post-stack header. And we're including, the control word as a post-stack header. Next slide. The recommendation is, if you want to do load balancing, do not use this hack that, if the first nibble is 4 or 6, it might be an IPv4 packet. It's really broken. Now, if the previous recommendation or requirement is used, this shouldn't be needed, but there's lots of implementations out there that do this. So if you want good entropy, if you want good load balancing, use an entropy label, use a fat pseudo-I label. Don't use that hack. That's pretty much it. I think that's the last slide.
So if people have got questions on this, we'll take those first, and then we'll take general questions and comments on the rest of on the work program as a whole, or other presentations.
So Tarek.
Again, my question is that there is some talk about application-aware routing, and routers would have to peek deep into the packet, figure out what application it belongs to. Maybe, I'm not sure if that is possible. Putting this recommendation, the one that you had on the slide, you should not decode or make any assumption what is the header type. Would make it hard for the routers to tell what is the application. Would it not?
Well, it would make it hard, but it's the right thing to do. We know that we already have the problem that if it's an Ethernet packet, and if it's an Ethernet packet without a control word, the first nibble could be 4 or 6, or it could be other things, because there is no, that's the part of the OUI field in an Ethernet address, in a MAC address. So trying to guess that the packet is IP by looking at that first nibble is just not a good idea. Whether you're doing load balancing or application-aware routing. So I think
Pseudo-I published a draft on this because we got into terrible trouble where people were doing this because there are some Ethernet frames starting to appear that were sent raw, as you can do over pseudo-I, and they were mimicking IP.
Yep. I think that's 4928 RFC. So I would say that the right way to do that would be to put a post-stack data that says, and I'm going to say this, please don't shoot me. This is a protocol type for the packet or something if you really want to get into application-aware routing. But just trying to guess randomly whether the packet is IP or not based on one nibble is not a good idea. Okay, I'm going to step away from the mic.
Yeah. Okay, so we have some pending questions, I believe, if anyone wants to raise them now. Loa, did you have anything particular you wanted to cover in this section?
I wanted to discuss has actually been in the meeting. I don't have anything in particular just now, and we don't have that much time.
Everyone I cut off earlier, I was asked to preserve this time. Greg, you go.
That I read all the proposals, and I support the working group adoption poll for their proposal that Kiredi presented. Thank you.
And then Wim.
Or Mayu?
Then
Hello?
Wim.
Hello?
Yeah, Wim Hendricks, Nokia. I think it's important to look at this backward compatibility thing. I was trying to chime in when Jeff asked the question, do we foresee a need that we need 8 of these things at the same time when forwarding a packet? I also believe that that's not realistic to do when you want to have very high performance routing, right? So that's why I personally supported Bruno's draft as a start, because it gives us a starting point to get going without probably have the full-blown extensibility that we want, but maybe it's enough to actually do the things that are really needed in a network. Because I was looking back when we did entropy label with Kiriti, which basically is 10 years ago, and even today there is many networks which cannot even deploy it because they have routers that don't support it, right? So we have to basically balance the solutions against how easy is it to deploy versus the amount of extensibility it gives. And I think this is a very important aspect we have to consider, because if you look to what happened with IPv6 and IPv4, it's incompatible, right? And we actually still struggle daily with this problem. And I think it's a very important aspect we have to take into account when considering the solution that we are going to adopt. Thanks.
Your last chance, otherwise I'll take you out the queue.
Hello? Yeah, so why there might be some reasons to support in-stack data, here I want to raise some concerns about actually using in-stack data. First, I think we lack of clear criteria to decide what data should be put in stack and what data should be put post stack. And also, there's evidence that, as Darren just mentioned, if we use bitmap to indicate the in-stack data, and also include the in-stack data in some labels, that will complicate the parser a lot. So, and also, we know, we understand there are already some labels other than indicating forwarding exists, like the entropy label. But that's a history before we have any other means to support those functions. But now, if we start to consider a uniform mechanism to do that, shall we continue to temper the label stack to make the label stack look, in my view, it's look messy and also makes the parser really complex. And also, I think okay, so first let's just state this these issues. I think we should have a clear understanding of that and the detailed analysis to decide whether or not we want to go this path.
Yes, Kariti, I think.
Yes, thank you. I just want to respond to Vim, and I think there have been some other comments along these lines before that 8 is plenty, and that's what we said about special purpose labels. So 16 is plenty. We defined, I think at the time 30, 31 came out, we defined 3 or 4 of them. Right now we have in flight 5 or 6 requests for special purpose labels before we started this work on the FAI forwarding actions indicator. So anytime you put a limit on things, you don't want to go overboard. You don't want so much processing in the packet that you can't actually forward things anymore. At the same time, I think we have to plan for extensibility. So the FAI proposal has in the first LSE potentially up to 11 bits that you can use for function or action indicators, but we might take away some of those. It has a second LSE that can have up to 30 bits. I think we need that. We defined extended special purpose labels, and we have a few that have been allocated. Anytime we think that we get comfortable, we're going to find that we've done ourselves an injustice. Thank you.
You're running out of time. Sorry. It's G next.
Can I quickly respond? I said 8 as a start. I'm not saying this is the end. I said 8 as a start.
Yeah, I think in the requirements, you hear me? I think in the requirement it mentions that it is important to maintain the backward compatibility and the efficiency of the Mpls architecture. And now we also want to introduce some flexibility to the Mpls forwarding. So I think based on some analysis and discussion in the design team, we have shown that it is maybe very challenging if we want to make further changes to the label format and to the processing of the label pop or label swap. So this is really something we need to consider. We need to be very careful about any changes to the label stack. And I think how you mentioned that there's some analysis about the forwarding efficiency and the performance. I think this is also useful if for every proposal we can have some hardware analysis provided so that we can prove that it can be introduced with a backward compatibility and efficiency. Okay, thanks.
Captain Sir, so my comments are very close to Wim's, right? I'm looking from deployability perspective. Looking at my network, I'm running, depending where you look, 3 to 4 generations of different hardware. Software is practically, it takes years to deploy. Forget about hardware. So I really need to start somewhere where I can deploy it on today's hardware, or actually yesterday's hardware, plus software to propagate basic stuff. Like, again, how deep can I go? What's the readable? All the stuff has been implemented last year or two, right? Even in open source software, if you look at open source routing stack, they all implemented extensions to IGPs and BGPLS last year. So in order to make it deployable, we need to start with something that is possibly already at least partially supported. Otherwise, we are talking 7-8 years from now, the whole upgrade cycle. I mean, we are IETF, we are doing running code, and we are trying to do something that's implementable, right? So this is where we should start.
Brief is possible comment, please, Darren, because we're running into overtime.
Yeah, the really brief comment, and I'll bring it up on the list as well, is I think with Kirti, with your draft, I think we have a problem when we go to bottom of stack data and additional control words exist after the bottom of stack. I'm interested to see how we solve that problem. So I'll bring it up online. Thanks.
Safar, same, please be brief.
So I agree with what Wim mentioned, so I'd like to echo her comment. I think Bruno's draft provides a very good start for the working group. Working group should start it for this work. 8-bit support is it provides good enough for the initial use cases, and then the draft also does not require any extension. Signaling extension is backward compatible. So is in my opinion very good start. The other point is that before working group adopt any solution, there has to be more discussion on the framework stuff that Lua and team started, and some other consideration within the working group. This is something for a long run, and we should not rush into one particular solution at the moment. We need a little bit more better baseline to start the work in the right direction for the long term.
Please.
Jeffrey from Juniper. So to add a follow up on Howie's comment on about the in-stack data. So allowing in-stack data does not mean that we would casually put anything into the stack. So I think architecturally we should allow it now, and in the future when any proposal comes up to add specific data into the in-stack for some functionality, at that time the working group will decide whether that's a good idea or not for that particular feature.
One other comment. So I agree with Wim on Jeff. I don't think I said 8 is plenty. I said 8, I'm saying 8 now is better than 20 tomorrow, and by tomorrow we mean decade. Plus, all proposals are extensible, so we can have 8 now and 20 tomorrow. Second, many networks, unless you have lots of money, are using multiple generations of hardware. It takes time to replace hundreds of nodes across a country or a continent or the world. So it takes really time to have a new feature supported on many platforms. That's the example with Entropy Level. It's incredible the number of times years required. I think it's fair to say that the IETF experience also with IPv6, which was not broadly available before we ran out of IPv4 address. So I think deployability is important in brownfield network.
Tianran?
In the queue have showed concerns. I share the same. From the solution point of view, there's no consensus. I do not think the working group should adopt several solutions with the same feature. And from the implementation point of view, there are several analyses on the hardware in the DT. You cannot convince most of people and cannot show any advantage and benefit. I don't think this is a good idea.
Very brief comment.
Ketan Talaulikar. I believe that MPLS working group should consider adopting draft Bruno for a solution that for things that can be tackled with it, today or sooner. And in parallel, the design team can continue working on the more elaborate framework and the analysis. But I think it would not be good to gate that proposal adoption on for the draft Bruno adoption.
Possible comment, Kariti, and then it really is the end.
Yeah, this is really quick. Before you take any decisions on draft Bruno or the other draft that says reuse the entropy label, please attend the talk in MPLS, by Stuart and Tony and someone else on the dangers of reusing or repurposing an existing SPL. Thank you.
Right. Well, thank you, everyone. I'm sorry I've cut a few people off. I'll see you in the MPLS, or I'll see you on the ODT meetings. So thank you all. That's we're closed for today. Encode, close this for me, or do I need to do something?